Hello, in this tutorial, we're going to be covering fractions in algebra. You'll learn how to convert between mixed numbers and improper fractions, how to write the prime factorization of a composite number, how to reduce or simplify fractions, how to multiply and divide fractions, how to add and subtract fractions with the like and unlike denominators, and how to solve problems involving fractions in algebra. So first off, mixed numbers are natural numbers, or what the term for it is whole numbers, plus a fraction without writing the addition sign. So here's an example of a mixed number. We have 5 and 3/7. So what this is saying, or what this represents, is 5 plus 3/7. We have the whole number, or the natural number 5, plus a fraction, which is 3/7. An improper fraction is a fraction that has a numerator that is greater than its denominator. So here's an example of an improper fraction. The numerator 14 is greater than the denominator 3. And because of this type of fraction is called an improper fraction. So how do we convert a mixed number to an improper fraction? First, we're going to multiply the denominator and the natural number. Then we're going to add the numerator. And then we're going to place the result over the original denominator. Let's go over an example. Here, let's convert 5 and 3/7 to an improper fraction. So the first thing we're going to do is take our denominator, 7, and multiply the whole number, or natural number, 5. So 7 times 5 equals 35. Now we're going to take this result, 35, and add the numerator, 3. So 35 plus 3 equals 38. Now we're going to take this answer, 38, and place it over the original denominator, which is 7. So we're going to take this denominator and just place it over here. So converting 5 and 3/7 to an improper fraction gives us 38 over 7. Now, how do we convert an improper fraction back into a mixed number? Well, first off, we're going to divide the numerator by the denominator. Then we're going to write the mixed number as the quotient plus the remainder over the original denominator. And then we're going to remove the plus sign. So let's go over an example. Here, let's convert 14/3 to a mixed number. So we're going to divide 14 divided by 3. Well, we know that 4 times 3 is 12. So we can write 4, 12. 14 minus 12 is 2. So now our mixed number is the natural number, our quotient 4, plus our remainder, right here, 2, over our original denominator, which is 3. Now we're going to remove the plus sign, so we have 4 and 2/3. So converting 14/3 to a mixed number, we get 4 and 2/3. Now, a prime number is a natural number that's greater than 1 and has only itself and 1 as factors. So what does that mean? Well, here are examples of prime numbers. Let's take 2 for example. Well, the only way you can get 2 is if you multiply 2 and 1. So that means it's a prime number. And the only way, another example is, let's look at 5. Well, the only way you can get 5 is if you multiply 5 and 1. Now, let's look at 11. Well, the only way you can get 11 is if you multiply 11 and 1. So a prime number is any natural number where the only way to get that number is to multiply itself and 1. A composite number is kind of like the opposite of a prime number. It's a natural number greater than 1, but it is not a prime number. So here's an example of a composite number. Let's take 4 for example. Well, to get 4, we can do 4 times 1, but we can also do 2 times 2. So because there's a multiple ways to get 4, that means it's not a prime number, it's a composite number. Let's look at 12. Well, we can do 12 times 1, we can do 6 times 2 to get 12, or we can do 3 times 4. So because there's a multiple ways to get 12, that means it's a composite number and not a prime number. Now, the prime factorization is the expression of a composite number as the product of prime numbers. It's breaking down a composite number, into individual prime numbers. So let's go over an example. Let's find the prime factorization of 60. Well, we know 10 times 6 equals 60. So now we can break down 10 into 2 times 5, because we know 2 times 5 is 10, times, and we know, let's break down 6, well, we know that's 2 times 3. So now we have 2 times 5 times 2 times 3, and all of these numbers are prime numbers. They're now prime numbers because the only way to get these numbers are by multiplying itself and 1. Now, if you multiplied these across, you would also get 60. So we broke down a composite number 60, the composite number 60, into the prime numbers 2 times 5 times 2 times 3. That's prime factorization. The lowest terms of a fraction is when the numerator and denominator have no common factors other than 1. So here's an example of a fraction reduced to lowest terms. Well, 3 and 7 have nothing in common. They have no multiple in common because 3 cannot go into 7 and 7 cannot go into 3. Now, the greatest common factor is a prime number that can be found in both the numerator and the denominator. So let's take 3 and 7. Their greatest common factor would be a number that can be found in both the numerator and a denominator. So let's look at 8/14. Well, right off the bat, we can see that they're multiples of 2. 8 is a multiple of 2 and 14 is a multiple of 2. So that means their greatest common factor is 2, because 2 times 4 we can get 8 and 2 times 7 we can get 14. So the greatest common factor they have is 2. Now, how do we reduce a fraction to its lowest terms? Well, first, we're going to find the greatest common factor that's found in both the numerator and the denominator. And then we're going to divide both the numerator and the denominator by their greatest common factor. Let's go over an example. Let's reduce 8 and 14 to its lowest terms. So we're going to take 8, 14. Now we're going to break down 8 into its prime numbers. So we can do 2 times 4, or 2 times 2 times 2. Now let's break down 14. So we can do 2 times 7. Or we can write that down here. 2 times 7. So now what we're going to do is cross out the terms that they have in common. So we know the term that they have in common is 2. We can see that in the numerator and we can see that in the denominator. So all we're going to do is just cross that out. Now we're going to rewrite our fraction as 2 times 2 over 7. 2 times 2 is 4, and 7 is 7. So here's our answer. Reducing 8/14 to its lowest terms gives us 4/7. Now, how do we multiply fractions? Well, multiplying fractions is the product of the numerators divided by the product of the denominators. So here's how we multiply fractions. First, we're going to multiply the numerators, and then we're going to multiply the denominators, and then we're going to place the product of the numerator over the product of the denominator. So here's how that kind of looks like. Let's go over an example. Let's multiply 2/7 times 5/9. So we have 2/7 times 5/9. So all we're going to do is multiply across. So 2 times 5, and then 7 times 9. Well, 2 times 5 is 10, and 7 times 9 is 63. So that's our answer. Multiplying 2/7 and 5/9 gives us 10/63. Dividing fractions is when a fraction is multiplied by the reciprocal, or what the correct term for it is multiplicative inverse of another fraction. What that means is you flip the numerator and the denominator. So here's how we're going to divide fractions. We're going to take the reciprocal, or the multiplicative inverse of the second fraction, by flipping the numerator and the denominator. So if we had a over b, we're going to flip it so that we get b over a. And then we're going to multiply the numerators, multiply the denominators, and then we're going to take the product of the numerator over the product of the denominator. So let's go over an example. Let's divide 4/9 divided by 3/7. So 4/9 divided by 3/7. So the first thing we're going to do is flip the second fraction. So instead of writing 3/7, we're going to write 7. Let me clear that out. 7 over 3. Now we can write our 4/9. And all we're going to do now is multiply. So now we can write 4 times 7 over 9 times 3. Well, 4 times 7 is 28. And 9 times 3 is 27. So that's our answer. Dividing 4/9 divided by 3/7 gives us 28 over 27. Now here's how we add and subtract fractions with identical denominators. We're going to add or subtract the numerators, and then we're just going to place the result of the numerator over the common denominator. Let's go over an example. Let's add 5/8 plus 3/8. So we're going to have 5/8 plus 3/8. So all we're going to do is just multiply the numerators. 5 plus 3. And then we're going to place that answer over the original denominator, which is 8. So now we have 5 plus 8 equals 8 over 8. So that's our answer. Adding 5/8 plus 3/8 gives us 8 over 8. Let's subtract 5/8 minus 3/8 now. Well, it's the same thing. So 5/8 minus 3/8. So all we're going to do is just subtract across the numerator. So 5 minus 3 over the original denominator. We're just going to place that right there. So 5 minus 3 equals 2 over 8. So that's our answer, 2/8. Subtracting 5/8 minus 3/8 gives us 2/8. Now we could reduce this even further if we wanted to. So 2/8. Well, 2 is a multiple of 2, so that can give us a 1. And then 8 is a multiple of 2, which gives us 4. So we can also say 1/4. Now, how do we add and subtract fractions with unlike denominators? Well, first we're going to find a least common denominator, rewrite the fraction using the least common denominator, and then we're going to add or subtract the numerators, and then we're going to put the result of the numerator over the common denominator. So let's go over an example. Let's add 3/8 plus 5/12. So 3/8 plus 5/12. Well, we're going to find a common factor that both 8 and 12 have in common. So we can write down 8 times 2 is 16. 8 times 3 is 24. Now let's see what 12 has. 12 times 2 equals 24. Well, boom. We see 24 here, and we see 24 here. So that means 24 is their least common factor. So now we're going to take 3/8 and our 5/12. So all we're going to do now is multiply by the factor to get 24. So in this case, our factor was 3. So we're going to multiply times 3 to the numerator and 3 to the denominator. And here, to get 24, we multiplied by 2. So we're going to multiply the numerator by 2, and we're going to multiply the denominator by 2. So now we have 3 times 3 over 8 times 3, which is 24, plus 5 times 2 is 10 over 12 times 2 is 24. So now we can rewrite this as 3 times 3 is 9 over 24 plus 10 over 24. So that gives us, write that over here, 9 plus 10 is 19 over 24. So that's our answer, 19/24. Adding 3/8 plus 5/12 gives us 19 over 24. Now let's subtract 5/8 minus 1/2. Well, we have 5/8 minus 1/2. Now again, we're going to try and find a common factor that 8 and 2 have in common. So let's just write 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Well, there you go. Boom. We see 8 here, and then we see 8 here. So that means 8 is our least common factor. So now we can rewrite our fractions, 5/8 minus 1/2. So now for here, for our 1/2, we're going to write the multiple. We're going to multiply by the multiple to get 8. So we're going to take our 4, and then multiply it, both the numerator by 4 and the denominator by 4. So now we have 5/8 minus 1 times 4 over 2 times 4. So we can rewrite that down here. 5/8 minus 1 times 4 is 4 over 2 times 4 is 8. So now all we have to do is subtract across. 5 minus 4 is 1 over 8. So that's our answer. 1/8. Subtracting 5/8 minus 1/2 gives us 1/8. So fractions appear throughout algebra. Many formulas and mathematical models contain fractions. Operations with fractions can be used to determine whether a particular fraction is a solution of an equation. Now, when used with fractions, the word of represents multiplication. Let's go over an example. Let's write 1/4 of a number decreased by 3 as an algebraic expression. So we have 1/4. Well, we said of, the word of means to multiply. So we can write multiply. Now we have a number, which could represent our variable. We'll say x. Now we have decreased by, which means subtract. So we're going to write minus. And then we have 3. So that's our algebraic expression. We can rewrite that as 1/4 x minus 3. So 1/4 of a number decreased by 3 is the algebraic expression 1/4 x minus 3. Now let's write 2/3 times x minus 7 equals 4 as an algebraic sentence. So now we have 2/3. We said multiply means of. Here we're multiplying. Let me rewrite that so it looks more pretty. So we have 2/3. Now we said multiply is of, so we're going to write of. And here we have our variable x, so we can write of a number. Here we have subtraction, so that means of decreased by. Here we have 7, so 7 equals, the equal sign means is, we represent that as is, 4. So there we go. 2/3 times x minus 7 equals 4 is the algebraic expression. 2/3 of a number decreased by 7 is 4. So that concludes fractions in algebra. For more problems and more tutorials on individual problems, check out our Introduction to Algebra workbook. If you need more personal help, more one-on-one help, we offer online tutoring. And in the next video, we're going to be covering the real numbers. Thank you.